This, we have discussed these kinds of numbers before, but let's just go through just to make sure that we're comfortable with them. If you see this n, so sometimes, for example, they might say that the universal set is on values from n, so you need to know what n means. All right, so if they've said that they are values of n from the set n, you need to know what they're talking about. If they're talking about n, we're talking about natural or counting numbers. So natural counting numbers are whole numbers, but they start at 0. Okay, so they start at 0. Z, you see this fancy Z, it talks about integers. We all know what an integer is, don't we?
Totally.
Yes, an integer is what kind of number? A whole number. It can be both positive or negative though, hence the plus minus in front of all of these. Okay, so an integer is a whole number. Z plus would be just talking about the positive integers. Notice they don't include 0 when they talk about Z plus, because 0 doesn't have a positive or negative version. Okay? And Q talks about rational numbers. I don't know if we've talked about this before. A rational number, most numbers are rational. Rational number is a number that can be written as a fraction. So even recurring decimals can be written as a fraction. Things that are not rational would be things like pi, square root of 2, and a few other square root numbers. But the majority of numbers are rational. Okay? R represents all real numbers. So we're talking about anyone and everything. Okay?
Except square root of -1.
Except for real numbers. For your benefit, all numbers. Not including non-real ones. Thank you. So, this is true or false. Give reasons for your answers. So, first of all, what does this actually ask? What is this asking? Shayla, are you able to tell me what does that mean? So tell me what that means. And what is the set Z? Says it in the list. So Z talks about all integers. So the question is asking, is 2 a member of the integers? Is 2 an integer? Well, remember what's an integer? So is 2 a whole number? Yes. So is this true?
Yes.
Okay, so we're all happy that A is true? Oh. So it's true because 2 is an integer. Maybe you could say that. Bracket whole number. And because that's showing the person marking it that you knew that Z was an integer. Okay? It's not good enough to just say true or false, because that's just a 50-50 hit and miss. You need to actually give a bit more information. And what does the next question ask, first of all? Jamie?
It's saying that it's a member of Q, which is the set of all rational numbers, so it's the P over Q.
So
It is.
it is?
Yeah.
It is not. Which one is it? You
Oh,
started
it
changing
is.
mine. It is, yes.
Because it has the 1 over 2. Or 2 and then 1 over 2.
So yes, so 2.5 is a member of the quotient, okay, is the member of that set, because 2.5 can be written as a fraction as P over Q. How would we change 2.5? What would it be written as in it?
It would be 5 over 2.
It would be 5 over 2, yes. So because we can change 2.5 to be 5 over 2, we know it is a member of that family. I'm not going to write now because it's going to make me cry. So you're going to write something like true because 2.5 can be written as 5 over 2, which is a quotient. The word quotient. Oh, they said rational numbers. Okay, so I need to correct it.
So would they have questions like that on the exam?
Unlikely. It would be nice if they were, but less likely. But you never know. Could be. In fact, I scrap that. They might, because they do have things like is so and so, is this true or false? or state what this means, and it's talking about a set in their diagram thing. They don't normally bring in these values, but they might. Quotient?
Oh,
No,
up there?
no, it's not. I keep calling it. Bless you.
So a quotient is a fraction.
It's a rational number, so it can be written as a fraction, yes. Okay, the next one. What does the next one say? Gabrielle, what's the next one actually are?
5 is not a member of rational numbers.
And is that true or false?
It's false. Because it can be a fraction.
Yeah, perfect. Perfect answer. 5, that's false, because 5 is a rational number. It can be written as 5 over 1. I'm going to do a little trying pausing because that's going to make me cry as well. Dinah, what does D ask?
Oh, 5 is a rational number.
Is that true or false? Good. Okay, so pi is a rational number. Pi is not a rational number, so that's false. And you could say something like pi is not a rational number. It cannot be written as a fraction. Or just saying it's not a rational number is sufficient.
Hey, but Miss Grayson, can't pi be written as a fraction because it's like...
It can be approximated,
Oh.
but that's always just an approximation. So often, like when, often it's approximated to 22 over 7 because it's close to it, but it's never an actual exact number. And the last one.
I have a question for Alger.
Okay, well, you can ask this one.
Okay, it's...
What does it
Why
say?
is it called pi?
Oh God, I don't know, darling.
I know. Okay.
What's pi? Oh, I was going to say, you know why it's called pi? I don't know, and I've never really cared. Sorry.
I think it's
weird. But Lily, why did you answer? Tell me what this says. What's this question asking?
Instead of negative 2, it's not a number of R set.
What's R?
Oh, it's not a real number.
So is that true or false? It's false. Okay, so negative 2 is a real number, so that is indeed false. Yeah, we good to go?
Wait, what's not a real number? Technically something.
So I said the main examples are things like pi.
Oh, okay.
No, shut up, not a real number. Square root of negative 1.
Oh, okay.
Sorry.
Other
examples?
Other examples, because you told me before that everything was like...
It's all based on I, square root of negative 1.
All of it?
Yeah, I and J, yeah.
That's good.
So, show, where's the I? Show, oh, okay.
Wait, what's J? Yeah.
Wait, no, just shut up, shut up me. And, oh my God. I'm going to do this really quickly because we have done it last year. But I don't know if it was recorded, so there'll be a good option to do it now. So, remember 0.36 with a line on the top, or it could have 2 dots, means 0.36363636. Okay? So what you do is you say, I'm going to say x is equal to 0.36, and there's a gap, I left a gap on purpose. So you would say x equals 0.363636, so on and so forth. Now, if there was just one digit recurring, I would then multiply this value by 10 and say 10x. But that's not useful for what I want to do. So what I'm actually going to do is I'm going to say, so 100x would be 36.363636. Okay, you all happy with that? Hopefully you remember this.
Yeah, I kind of remember.
So now what we can do is if I've got 100x equals this bad boy and x equals this, I can subtract one line from the other. So I can say 100x subtract this x leaves me with 99x, and 36.363666 subtract 0.3636 means it's just 36 because I made sure that my 36s were all lined up. Hopefully you all appreciate why I didn't say 10x, because if I'd said 10x, then my 6s would be above my 3s and it wouldn't cancel each other out. Yes? So you always have to make sure that the thing that's recurring here is the same as each other, on top of each other. And then if 99x equals 36, that means that x is 36 over 99. And we said that x represented our recurring decimal, so therefore our recurring decimal is 36 over 99, and hence I've written it as a rational number. Okay. There are several other examples of those things. I can find the textbook for you. You will find there's a lot of nines generally involved. So it's either 99, 9, 90, 900, those kinds.
Wait, can you also look at it? Oh yeah, I was just gonna ask you if you can find one just like it.
Yeah, you can totally simplify that, can't you? Three goes into it.
No, before or
Oh, 9 is into it. Yeah,
Yeah.
some notes. Yeah.
Would they prefer that or
Yes, you actually probably should always
Okay.
simplify. Probability is the only time you don't have to, so I apologise and do checklists and produce it.
Oh my god.
Let's go.
She says that.
I said it was fine.
No, you don't.
Alright, so interval notation. So this is another way that we just combine some numbers. We definitely talked about this when it came to inequalities. Yes? Do you remember this? Oh, where we haven't really looked at it.
Oh yeah.
Alright, so what this fancy pants thing here is that you're really just focusing on this bit here. And that is telling us we're talking about numbers between -3 and 2. It's not including -3, but it is including 2. Now, this part here, this x is a member of the real numbers, tells us that it could be any number in between there. So it could be 0.117, it could be 1.32796, it could be any number in between them. What you have to be careful of is if this instead was a z, because it's indicating it would be an integer only. Okay? So just be careful that you're looking at the numbers that they're including in your sets. I don't think, so for example here, this one here, says -5 to 5, so it's not including either of them, but it's actually only including the integer values. So we're only talking about -4, -3, -2, -1, 1, 2, 3, 4. Okay? Did I say 0?
No.
Including 0 as well. So it's just so you know what these letters mean as to which numbers you're interested in. So write in interval notation, how could I write this?
What is the x with the line at the beginning?
Oh, so you don't have to write that. It's just a fancy way of writing things. This is the important bit.
Yeah, what did you ask?
So what's it? It says x with a line through, like with a line down it. Like it's unnecessary. Which values are we talking about here? So how would we, there are a few ways that we could write this. So we're talking about just integers. So x is a member of the integers. That's a normal set E. And which values are we interested in?
1, 2, 5.
So we could,
1, 2, 3, 4.
okay, so we could do this,
Oh, shoot. Yeah, that's what I was
okay? Or you could do this. Okay? Both of those give you the same because we're only talking about integer values. So it wouldn't include the 6 and the 0 anyway, and there would be no other numbers. So you can have either of those two. Both of those would be acceptable.
Could you take the greater than 0 but less than or equal to 5?
Yeah, you totally could do that. So there, and you, in a similar way, you could do equal to 1 and less than 6. Yeah. So there are lots and lots of different options. So just be aware of the fact that if you have something different to someone else, it doesn't mean that one of you has it wrong. You could both be right as long as you've got the correct signs there. Now this one here, oh sorry, is there a question?
Yeah. Does the whatever we put have to go before the x,
It doesn't have to. You could do, makes no major difference as long as you've got those bits of
Why is the
information.
x in the
because it's showing it's just these numbers.
Oh,
That's what I'm going to
right.
say for this next
Isn't that
one.
the same as just writing one?
No, because if you had just said this, you could have meant 1.7,
Okay.
and you're not allowed 1.7 because it's just those numbers there. Yeah?
So you use the thing, that,
The inequality.
those equals.
And then you say X, no, you say that,
Yeah.
and then you say X is a member of, just the same way as they did up here.
Okay, still a comma.
Yeah. What about the next one? Oh, another question?
Do you have to put the comma or?
No, I think as long as you've got the information there, they're not going to be too particular to that. And what about B?
So you would do
Go on, Gabrielle.
-3, more than X and then 6. Well, this one and 6.
Okay, and what would we say about which family is it in?
Z?
Okay. So Z's no, not for this one. Sorry, apologies.
I don't know, I just guessed.
So why do I know this one is not the integers? Yeah?
Not like, so it would have
Yeah,
to be
because
this one.
you can include all of them. Yeah? So this one is more likely to be the real numbers. Okay?
We have to know that. That's an X.
I thought-
Yeah, that's why we do this, so you just recognise what they mean. To be honest, the Z and the R are the ones mostly used. They're the most okay? Alright, yeah, so let's do this example. Let the universal set be the numbers from 1 to 20 inclusive. Okay, so remember we always want to make sure that we've labelled our universal set. Set A contains even numbers and set B contains prime numbers. So, my suggestion is that, well, the first question says write set A and B, using set notation. So, even if the question doesn't ask you to do this, if you're drawing a Venn diagram, you need to identify which values you're looking at. It's very hard to do something in your head, so it's a good idea to actually list them. So, I've listed my even numbers between 1 and 20 inclusive. Why did I stop at 20?
Oh,
Pardon, Joe?
this is including 20.
But why did I not write 22, 24, 26, 28?
From 1 because 1 to 20.
Yeah, because you're always looking at your universal set. Yeah? So that's really important. So B, I've written down here, I should have asked you to listen to me. So 2, 3, 5, 7, 11, 13, 17, 19, they're my prime numbers, again within that range. So B has asked us to fill in the Venn diagram. So what was the tip from last lesson? What did I say we should always start off with?
What do they have in common?
What do they have in common? What do they have in common?
2.
Okay, so 2 is the only bad boy in the middle. You can then label these however you like. I'm going to label A and B there. So now what we have to do is list everything else within circle A. So I've already got 2 written in, so I now need, oh, this is going to be a disaster. You're going to write them in this area here. 4, 6, 8, 10, 12, 14, 16, 18, 20. Sorry, it's too little. And then in a similar vein, in B, so in this crescent moon here, you're going to write the numbers 3, 5, 7, 11, 13, 17, and 19.
Why aren't they outside of the circle?
Pardon?
Why aren't they outside of the circle?
What, answer or are?
Aren't they?
Well, then my next question to you is, are we done once we've done these things?
No.
Why not, Emma?
Because the universal set is from 1 to 20, and the names of the things on the outside of the Venn diagram are the things that are not included in the that are included.
Good. So you've listed a lot of numbers in here,
Oh,
yes? But we need to go from 1 to 20. So we need to check, have you included all of the numbers? So I know 1 is not in either of these 2 sets, so I know 1 goes outside here.
15.
9. Ooh. 15?
Yeah.
No. 15? Any others?
0.
0 is not included because we go from 1 to 20. Okay, so there we go. what did I say here? Don't forget to include the rest of the as a set. These go in the box around the set. So in this case, those it will be those numbers between 1 and 20 which are odd and not prime. Yes. In some questions, you'll be given the Venn diagram and asked to identify certain features. So, remember, what did this mean? Shayla, what did this mean here? This horseshoe? Yep, so for my Venn diagram, which values are they? So ideally, you write them in those curly brackets, 1 and 64. Casey, what does the other one, the other way of horseshoe mean?
Is it like the ones that are not extended to the Venn diagram?
How do you mean?
Like 1, 9,
No. And we're looking at this diagram now, too.
Oh.
But no, not that. Oh. That's not that. So what does this symbol here? Are you 2 people in the classroom?
I knew the first one, right?
Unfortunately, sorry. Picture of the one. Brianna?
It's the ones that they don't have contact, so all of the ones in the
Not quite. But I liked your last statement, but not the first thing you said. You said the things that they don't, all of the ones that they don't have in common. Elena?
Is it all the elements in more than one set?
Yeah, so tell me what I would list.
I had 1 and 64 that I could.
That's just the intersection. Alright, this you, Mia, everything in both sets. So when you said the things that are not in it, you actually do include those. So see, it's the basket. See, your basket you remembered. No one remembered mine that everyone do 90.
I remembered it. What did you say? I didn't put my hand up. I forgot.
So you put your way down.
Yeah, because you called on Brianna and then I just didn't want to do anything.
Well then after Brianna, I called on Mia.
Yeah, but once I was being denied, I didn't want anything anymore.
Alright, so the U means union. So it's things in union. So it means everything that's in C but is also in D as well. Okay? So you're listing all of these numbers. So when you're doing this in the exam, you don't have to do them in numerical order. What you might want to try and think is that some person is going to be marking these exams and they're marking lots of them. You want to try and keep them as happy as possible and you want to try and make sure they're not making mistakes. So if you have it in numerical order, then it might be easier for them. But it's not the rule. Okay, so I would list 1, 4, 9, 16. Oh, I missed 8. Oh, shush now.
Oh, wow.
I'll just keep going. 25, yes. 49, 26, 8, 27. And those bad boys would be in brackets.
You're good.
So I've listed my union. Okay?
What about
Oh, we're all good. And 64.